Hello, this is Adam Betts, and today we're going to be covering question 11 and 12 of how to think like a computer programmer. Now, question 11 and 12 as well has us revisit the drunk pirate problem from the exercise in chapter 3. Well, this is the exercise in chapter 3 that is the drunk pirate problem. So first, let's see what we did before, so we kind of have an idea where to go to. We set up our turtle module, we set our screen size, our background color turtle, and we had a set of movements. The movements were set by the turns, and the pirate would turn and go forward a set amount of distance each time, but it would be the exact same each time. And when we do this, we see that turtle goes around, does some zigzaggy moves like a drunk person. But this time around, our social science student now records pairs of data. He records not only the turn, but how far he moved each time. So this looks a little bit more realistic as to how someone might drunkenly stumble. Well, this data is saved as a tuple. And the neat thing about these coordinate pairs, and since they're tuples, is we can go ahead and bring these in just like that, and we have in a list. Well, the brackets here indicate this is a list now, and each of these terms in parentheses are one term. So this is only 4 separate terms. It's not 8. So, and it's already set up in nice little pairs. Well, the way we can use this is if we were to run our Python shell and we were to, let's just run this as it is, it's going to error out. We know this, but if we were to pull up our drunk, we see that we have our pairs. Well, the reason now we can use this in the original turn modules. So we go for our A in drunk, and we're going to go through a little for loop on this actually we can use for I and drunk, I'm sorry, and we can, for A and drunk, we're going to set these two values to two different variables. We're going to have a turn, and let's just make it t for simplicity, and let's have the forward be f. Now if we were to set t comma f to I, we would be able to set this term right here to 160 to t, f would be 20, and it would execute this program. If this works right, we see this little zigzaggy movement, which looks about right. We're going to just move these up by a factor of 10 real quick, and to better illustrate what exactly is going on, and bring this up here so it's in one line, and you can see a little more clearly. It's doing the same drunk path. The distance is dynamic depending on the tuple. So yeah, this is it. So now we have easily done homework 11, 7, 11, and 12. Let's just go in through the and 12 there, because that's kind of what it is. And that is it. It is that straightforward. This is how to use a list of tuples, and this way you can split them up into 2 different elements. You can split them up, the first and the second terms, and go from there. It really is that simple. This is Adam Betts, and hopefully you learned something new today and a little better way to look at this. Have a great day.